half-life video 2, we saw that the half-life is the time taken for the number of radioactive particles in a sample to halve. So what that means is, after one half-life, only half of the original radioactive nuclei remain. If we went on for another half-life, then we'd have a half of that half remaining. So that means after two half-lives, we'd have a quarter of the original amount of radioactive nuclei remaining. If we went for three half-lives, we'd have an eighth of the original number of radioactive nuclei remaining. Four half-lives would be 1/16, 5 would be 1/32, and so on and so forth. Let's look at it visually. So we have two elements here, just call them element P and element S. Element P is a radioactive element, and we have a sample there with only element P. When it undergoes decay, it becomes element S. And what we are saying here from this graph is the half-life of the radioactive substance P is 14 days. So after 14 days, the container, which was full of element P, will now only be half full of element P. So that's one half-life. Over the next half-life, this half here halves once more. And over the next half-life, that halves once more. So comparing it to the original amount, after one half-life, we have half of the original amount. After two half-lives, we have a quarter of the original amount. After three half-lives, we have an eighth of the original amount. After the next half-life, we have a 16th of the original amount, and so on and so forth. Looking at it visually in another way, if the 1 represented 100%, the half represents 50, this represents 25, and so on. And we have time there on the y-axis. So if we had 100% of the sample was radioactive at the start, after one half-life, there'd only be half of the original amount still radioactive. So after one half-life, if we went up to the graph, we'd have half there. So that height, half of that is 50%. That's half the original amount that's radioactive, and the time taken for that to occur is the half-life. So if we then went from 50%, if we half that again, so to go from 50% down to 25, what we have there is this time is another half-life. So obviously, the total time is two half-lives, and over two half-lives, an original sample decays to 25% of its original amount. After three half-lives, to an eighth of its original amount, and so on and so forth.